The rules for working with products and quotients of square roots can be extended to products and quotients of nth roots. Prime factorization can again be useful as an aid for simplifying. Here we have the quotient rule for nth roots. The nth root of a quotient, or this rational number, is equal to the nth root of the numerator divided by the nth root of the denominator. And let's take a look at an example using that quotient rule. Here they're asking us to take the fourth root of 81 over 625. This rational number has no common factor and cannot be reduced. However, using the quotient rule, it can be expressed as the fourth root of 81 over the fourth root of 625. Simplifying each of the numerator and denominator's expressions is possible now. The fourth root of 81, since 81 in prime factorization is 3 to the fourth power, and the prime factorization of the denominator, 625, breaks down into 5 to the fourth power. Then, taking the nth root, anytime you have an index of a radicand with that same power, we will get the base of 3. And here in the denominator, the fourth root of 5 to the fourth power results in 5. So our simplification of this quotient is 3/5. Here we have another example. They're asking us to take the cube root of this rational number 2 over 125. As a rational number, there's nothing common between 2 and 125, but if we apply the quotient rule and take the radical of the numerator and the radical of the denominator, we can simplify. Cube root of 2, nothing can be done since 2 is a prime number and the only factor there. However, the cube root of 125, since 125 in prime factorization is 5 to the third power, can be simplified. So our final answer will be the cube root of 2 over the cube root of 5 to the third power, which is 5, for our final answer and simplification of this problem.